for the brute force method. E.2, string matching problem. All right, string matching. So it's another simple computing problem, but this problem is very useful for string-based search. Okay, keywords-based search. Think about that. Keywords-based search. Yeah. People use a lot keywords-based search every day. Yeah. And there is some algorithm behind it. And here I just talk about the brute force method, because there is a much more advanced algorithm in our textbook, much more advanced. Yeah. All right, so here, mathematical representation. In order to solve this problem, string matching problem, you can guess, string matching problem, I will give you a description quickly. Yeah. But we need to use some mathematical representation on it. Okay. Problem number 5, string matching. Problem description. Given a string of n characters, a block of text, so we call it text, n characters, and a string of m characters, we call a pattern. And we assume m less than or equal to n. The pattern, we mean a keyword, smaller string keyword. So n with m characters. So find a substring in the text that matches the pattern. That's the problem. String matching problem. Okay, yeah. Here, the brute force method, I guess everybody can apply the brute force method to find a solution. Okay, yeah. Here, we do discussion. But we need to work on the mathematical representation first. All right. Yeah. So the solution means you need to find the location of the pattern, the substring that corresponds to, that matches the pattern. Okay, yeah, location. Yeah. All right. Yeah. But for the location, you need to interpret what is the exact meaning of the location. Here, the meaning is the index I of the leftmost character, not the rightmost, not anyone in the middle, just the leftmost index I. Okay, yeah, all right. Yeah. First solution. Straightforward thinking. We do not need to use any fancy method, just straightforward, based on our intuition. Okay, so we do the comparison, substring comparison, one after another. Okay. But we cannot do it mentally, so we need to write out the expressions, specific expressions first. Okay, write down on the paper, so then we can see the expressions clearly. Okay, not mentally, yeah. On paper clearly. Okay, yeah, all right. Because if we have mathematical representation, then we can apply mathematical tools. Okay, so we may have some formulas, some special methods. Yeah. If we do not have the mathematical representation, then it's not convenient to apply any mathematical tool. Okay, yeah. All right. Text. What is the mathematical representation for the given block of text? A sequence of characters, right? And also, we need to mark the location information for each character in the text. Yeah, so here we use this way. T, because text, each character in the text, we use little t, and the location information, we use subscripts. The index of each character in the character array. Yeah, we can treat it as a character array. Okay, yeah. With indices from 0 through n-1. That is the first representation. Second, the pattern. We use P. Yeah. So P sequence, character sequence. Yeah. And with indices from 0 through n-1. Yeah. With these two expressions, then we can do discussions. We can write detailed discussions clearly on paper. Okay, yeah. Not in our mind. In our mind, we will get lost quickly, right? Yeah, so we will get lost. Yeah. So we need to write it on paper. Yeah. All right, requirement. Find the location. What do you mean find the location? Find the location I. Yeah. So let's describe a typical matching case. Matching, substring matching case. Yeah. I such that T sub I equals P sub 0. Yeah. P, the first character in the pattern, matches the substring, yeah, whose first character is at location I. All right, yeah. Then T sub I plus J, yeah. So you move position to the right. So I plus J. I plus J means you move J positions to its right. All right, yeah. So this one usually a little harder for some students to understand. Yeah. All right. So you move the pointer. Yeah. All right. Move the pointer. Yeah. Okay. To the right. Yeah. In T sequence, if you move the pointer one position to the right, so in the P sequence, you also need to move the pointer from one position to the right. At a T position, you move to J positions to the right, and P sequence also J position to the right. Okay, yeah. One by one, one-to-one correspondence, all matching, yeah, until you reach the last character of each sequence. Okay, yeah. The last one, T sub I plus n minus 1 equals P sub n minus 1. Okay, that's the expression. Think about that. If you can understand this sequence of expressions for a matching case. So that's the matching case. Okay, it's a matching case. That's the matching case. Okay, all right. Here's the strategy. Here, guess and verify strategy. Yeah, because in order to solve this problem, yeah, although it's a simple problem, but in order to find a solution, in order to, get a correct formula, here we use the guess and verify strategy. Yeah. All right, so let me describe it. Yeah. Thinking. Yeah. Let us do the thinking here. Yeah. All right. Question. Can we exhaust all such M substrings? No. When you do the matching, if we can exhaust all M substrings in the given text, then we can complete all possible comparisons. We can make all possible comparisons. So here we need to answer this question first. We have finite many characters in a given text, finite many, so we can exhaust. That's easy. Yeah. Moving from left to right, because every time we only look at M adjacent, M consecutive characters. So we can easily exhaust all substrings containing M consecutive characters. Okay, yeah, all right. Yeah. So to get a step-by-step procedure, step one, every time we extract one M substring from the text with consecutive characters. Okay. Every time we just take out one M substring, yeah, with consecutive characters. Okay. Step two, compare it with the pattern for a possible match. Yeah. All right. So this kind of comparisons, one after another, in order. Okay. Yeah. Then another question. How many such M substrings? How many M substrings do we need in order to exhaust all possible substrings, M substrings? Okay, there must be some number there, right? And it should not be that hard to find that number. Okay, yeah. But here, I like to introduce some method. Things like this is pretty easy, yeah, but I like to introduce some useful method for you to find the answer. Okay, all right. Yeah. So before we apply that method, so here, yeah, because guess and verify strategy, in order to get this answer, guess and verify strategy, yeah, how many M substrings? Yeah. All right. So you may need to imagine. All right. So suppose this is the text. Okay. Yeah. With N characters, the length is N. Length is N. All right. Length is N. Then the pattern usually smaller, right? Pattern. Okay. Pattern much smaller than the text. The length is N. Okay. Yeah. All right. So the first substring, when you start from the left, you take M consecutive characters from the leftmost point to get started. Then every time you move one position to the right, yeah, until you reach the last M consecutive characters. n, length n, all right? Yeah. And how many different steps you can move to reach the last m substring. Okay, yeah. Here, guess first. An obvious guess, n minus m, right? Yeah, because you know, based on our intuition, right? Yeah, but your guess may not be correct. You need to verify it. Yeah, guess, then you need to verify it. Your guess may not be correct. Okay, yeah, many times it's not correct. We need to fix it. Okay, yeah, how to verify it? Here, a simple way. Try to find some simple case. You can find the answer easily. Yeah. So what's the simple case? Extremal case where m equals n. That's the one extremal case. The pattern and the text, they have the same length. When they have the same length, the answer is 1, right? So there is one m substring in the pattern, only one, not 0. Yeah. But this n minus 1 gives you 0, right? Yeah, your guess is not correct. Your guess is 1 away from the true answer, or 1 less than the true answer. So you need to do the adjustment. You need to add 1 on top of your guess to get a correct answer. So then you fix it. So the correct answer should be n minus m plus 1 to fix it. Okay, to fix it. So in this way, so this is a simple method, guess and verify strategy, but you try it on a simple example. So you can handle easily on that simple case. Yeah. So here you get the idea. Okay. Guess verify idea. Okay. All right. Now, next one, we need to count the number of comparisons. We need to count the number of comparisons. Okay. Although it's not hard. It's not hard, okay? Yeah, actually it's pretty straightforward. Yeah, pretty straightforward to count. How many character comparisons you need to do here, okay? Yeah, implementation details. We need, when we do implementation details, yeah, so we need to do a for loop, right? We need to run a for loop for the character comparisons. All right. So when we do a for loop here, let us apply for loop on the sequence of characters in the given text. Here in this diagram. All right. And we start in our for loop, we start from the first m substring. Yeah. Then when we start the position number, yeah, the subscript of the first character equals 0. So the position, location of this m substring is 0. All right, yeah. Then when we reach the end of the last m substring in the given text, so we need to figure out the location of the last m substring. So that question mark. So at this point, we may not be able to guess correctly. So what should be the correct location of the last m substring? Okay, we need to figure that out. After we figure that out, then we can write that for loop. easily. Okay, yeah. But this question mark still, it's a small problem, but we need to solve it first. Okay, yeah, here. The question, how to solve this problem? The question, how to figure out the subscript? Yeah. Right. If you just guess, how do you know your guess is correct? Right? How do you know your guess is correct? You need to find a way to verify it. Verify your guess. Okay, yeah, all right. So you can apply our previous strategy, the strategy from our previous slide. But here, I like to introduce another problem-solving thinking method. So very useful thinking method. I like to introduce that one. Yeah. Because later we will use this method a few more times. Yeah. All right. But today we do not have that much time to talk about this method. Yeah. I will leave this method next time.